Okay, now let's look at the shell around the x-axis. So I've got a region R in the first quadrant. It's bound by the graphs y equal the square root of x minus 2. Okay, the square root of x minus 2, and you know what the square root of x looks like. We're just going to shift that over 2 units, and so we'll have the square root of x minus 2. Okay, and the line y equal to 2. Okay, now let's see where these are going to intersect. If y is equal to 2, and the other curve is square root of x minus 2, that means that 4 will be x minus 2, so that means x will be 6 when they intersect. So let's see, I just want to get that intersection point pretty close. 3, 4, 5, 6. So this would be where the y was 2. Okay, so let's see. First quadrant bound by those 2 graphs. Okay, so the region that we're looking at then is going to be this region right here. And now we're going to rotate that around the x-axis. So be sure you pay attention to which axis you're rotating it around. Okay, so now you've got to figure out what will my representative rectangle look like. You know, what piece am I going to take and rotate it around the axis? Now, if you want to use the shell method, which is what we're going to practice here, you need to choose a piece that's parallel to the axis you're rotating it around. So to get a shell, pick an arbitrary value here. Now, you can choose any horizontal piece from y equals 0 up to y equals 2. You know, you could choose it here, you could choose it any of these places. But pick an arbitrary one, that's an arbitrary y value. So that any horizontal piece like that corresponds to some constant y value. Okay, so let's say I'm looking at this piece right here, and I'm going to rotate that now around the x-axis. What I'm going to get by taking this one little rectangle here is I'm going to end up getting the shell generated by that little piece. And so my goal is to find the volume of that shell. Okay, so now looking at that piece, you've got to decide, okay, using the shell method. The shell method says that the volume is going to be the integral 2 pi times the radius of the shell times the height of that shell, and then times the thickness of it, which will be the dx or dy, depending on what variable we're going to need. So let's not worry about that right now. Let's just see what the radius looks like. The radius here in this picture, the radius for this cylinder would go from the axis out to the edge of that cylinder. Okay, so what does that correspond to? Well, that corresponds to that y value that we chose to form the cylinder for. So the radius here will just be 2 times pi times the y value. Okay, because I chose the y when I chose this representative rectangle here. I was looking for something parallel to the x-axis. That's just an arbitrary y, and that does define what the radius of that cylinder is going to be. Okay, now the height of that cylinder. The height of that cylinder, if you look at the picture, is going to actually go from here up to here. Okay, the height is in this direction. Okay, it's actually this length from here to here. It's the length of that segment that I chose. Well, what's determining that? What is that length? That length is going from the y-axis out to a point on that curve. That's what stopped me when I drew that thing. And so that's just going to be that is it an x or a y value? Since it's a horizontal distance, it's actually an x value, but it corresponds to whatever this curve is here that stopped it. So it's going to be the x value for this function. Okay, so the x value, we need to figure out what the x is there. Well, y is the square root of x minus 2. That means that y squared will be x minus 2. So that means x is y squared plus 2. So the x value that is the height is y squared plus 2. Okay, so here's my height. This was the radius. I have 2 pi. I'm obviously going to need dy. That's the thickness of that little rectangle that I drew. It's the delta y. And now because I'm dealing with y's, you know, what possible y's could I consider? I was considering anything from y equals 0 here up to the top of that that shaded region, so that's y equal 2. So from 0 to 2, and so now we have 2 pi. I'm just going to pull that all out. I have the integral of y cubed plus 2y from 0 to 2, and that's going to be 2y times y to the 4th over 4 plus y squared. And now I want to evaluate that from 0 to 2. Okay, so now I have 2 pi times 2 to the 4th is 16 over 4, so that's going to be 4 plus 2 squared is 4, and then minus, and I'll get 0 for everything when I put in y equals 0. So I'm going to have 16 pi, and that'll be the volume of that solid that's created by rotating that region around the x-axis.